Since humanity first grasped the vastness of the universe, a persistent question has lingered in many minds: why haven't aliens come to colonize Earth? Why haven't we discovered any signs of extraterrestrial civilizations? There are several possible explanations for this mystery. First, it's important to distinguish life from civilization. Bacteria, worms, ants, or even pigs, dogs, and monkeys do not constitute a civilization. A civilization refers to a form of life capable of creating things that do not naturally exist, allowing them to better adapt to their environment, solve problems, and enrich their lives. Civilizations manifest in aspects like language, culture, technology, laws, and art. Within the vast universe, Earth might be the only cradle of civilization, representing the pinnacle of existence in the cosmos. The emergence of life is no small feat, requiring a perfect convergence of conditions, favorable timing, location, and circumstances. The prerequisites for life are exceedingly stringent. During the formative stages of any planetary system, chaos reigns. Countless celestial bodies collide with one another, gravitational slingshot effects create unpredictable orbits, and the central supermassive black hole of a galaxy can render entire regions unstable. In such a chaotic environment, a planet surviving for billions of years without catastrophic disruption is incredibly rare. For example, Earth endured significant impacts early in its history, including the famous Theia collision, which scientists believe created the Moon. But surviving these formative periods isn't enough. For life to arise, a planet must meet a host of other strict criteria: a thick atmosphere, a strong magnetic field, a suitable moon, liquid water, and an optimal position within its solar system. In our solar system, no other planet or moon meets all these conditions simultaneously. Take Mars, for example. It may have been habitable billions of years ago with liquid water, but the loss of its magnetic field caused its atmosphere to be stripped away by solar winds, leaving it a cold and barren wasteland today. A star system also requires a relatively calm star. Violent stellar events, like supernovae and gamma-ray bursts, can annihilate all life within tens of light years. Furthermore, the location of a solar system within its galaxy matters. Dangerous regions like the galactic center, spiral arm edges, or areas near black holes are unsuitable for the development of life. While the conditions for life are extraordinarily demanding, the sheer number of galaxies in the universe suggests life might still emerge frequently. However, the universe is rife with hazards that make life even harder to sustain. Beyond supernovae and gamma-ray bursts, there are cosmic microwave background radiation, cosmic rays, black holes, neutron stars, rogue planets, and interstellar dust, all of which threaten the fragile emergence of life. Given these challenges, some believe life in the universe is exceedingly rare. The odds of life emerging require countless coincidences, and perhaps Earth is the only life-bearing planet in existence. If Earth truly is unique, then humanity is unlikely to ever discover alien life. Consequently, fears of extraterrestrial colonization are unfounded, as no such life exists to pose a threat. According to scientists, most stars in the universe are red dwarfs, orange dwarfs, or yellow dwarfs. Massive stars with short lifespans are relatively rare. The Sun, a yellow dwarf star that has existed for 5 billion years and will likely persist for another 5 billion, is considered a long-lived star by cosmic standards. Interestingly, even though red dwarfs have only a fraction of the Sun's mass, sometimes just a few percent or even thousandths, they are so abundant that scientists believe life could potentially develop around them. However, red dwarfs have a significant drawback: they are highly volatile, frequently emitting powerful radiation bursts capable of destroying the atmospheres of nearby planets. For example, Proxima Centauri, the closest star to Earth at 4.22 light-years away, is a temperamental red dwarf. Observations reveal that Proxima Centauri periodically produces intense flares. If such flares were to occur near Earth, they could easily strip away our atmosphere, leaving the survival of humanity in doubt. While scientists speculate that life might exist near Proxima Centauri, this hypothesis primarily stems from the discovery of a planet in its habitable zone, Proxima Centauri b. However, due to the star's volatile nature, the planet's ecological environment is likely harsh. Although it may host life, the development of intelligent life or advanced civilizations seems highly improbable. Thus, some scientists argue that while life may be common in the universe, the prevalence of volatile red dwarfs means it is challenging for life to evolve into advanced civilizations. Despite the vast number of galaxies in the universe, the number of civilizations may be quite limited, which could explain humanity's inability to detect extraterrestrial civilizations. One significant reason why most life in the universe struggles to evolve into advanced civilizations is the volatility of their host stars. In addition to this, a planet's inherent conditions play a crucial role. For example, a planet needs a stable ecological environment to provide life with the time needed to evolve and develop. Earth, fortunately, meets these conditions. On Earth, all living organisms are subject to aging and death. When organisms die, they decompose and return nutrients to the soil, which plants then absorb. When plants die or shed leaves, they, in turn, nourish other organisms. This natural cycle, known as the material cycle, ensures that resources on Earth are replenished and sustain life. The material cycle allows Earth's ecosystem to thrive, enabling its biodiversity to flourish and eventually lead to the emergence of intelligent life. However, not all planets in the universe are capable of sustaining such cycles. Some planets lack the ability to recycle materials, and scientists refer to these as dead planets. In addition to the material cycle, the availability of elements, particularly metals, is critical for the development of civilizations. Earth is rich in a variety of metals, which have been essential for technological progress. On planets where metal resources are scarce, civilizations may stagnate or collapse due to resource depletion before reaching higher levels of development. While life may have emerged countless times throughout the universe, these life forms often encounter numerous obstacles during their development. Some civilizations arise near volatile stars, making sustained progress nearly impossible. Others may form on dead planets that lack material recycling, or on planets with insufficient metallic resources to support further technological advancement. Such civilizations inevitably face extinction, leaving them unable to develop interstellar travel capabilities. In the vast and boundless universe, the spark of life may have ignited in countless corners, but not every civilization endures long enough to reach the pinnacle of interstellar travel. Some civilizations may have faced irreversible disasters, such as sudden stellar changes, planetary environmental shifts, or internal conflicts leading to self-destruction. These civilizations are now long gone, their remnants lying dormant in the cosmic expanse like ancient ruins, waiting to be discovered. Other civilizations may have nurtured intelligent life, but remain in their early stages of development, far from achieving interstellar travel. They are likely preoccupied with solving basic survival challenges such as food production, energy acquisition, and disease control. Lacking the technological and material resources to explore the universe, these civilizations, like Earth's early tribes, are confined to their home planets. They gaze at the cosmos with curiosity, but remain bound by their limited technology and understanding, quietly toiling on their own worlds. The solitary watchers of the universe ****. In the vast expanse of the cosmos, galaxies glimmer like precious jewels scattered across an endless dark canvas. While humanity's dream of interstellar travel remains undeterred, even our most advanced technology seems insignificant compared to the universe's enormity and depth. Against this backdrop arises a compelling hypothesis: some alien civilizations may have overcome the barriers of interstellar travel, but they are not within our Milky Way. Instead, they dwell in galaxies located billions of light-years away. Although these civilizations might possess extraordinary abilities to traverse the stars, the staggering distances involved make even near light-speed travel an endeavor requiring millions or billions of years, along with incomprehensible amounts of resources. Thus, despite their potential curiosity about our galaxy or even awareness of Earth, the cost of such a journey, both in time and resources, would far exceed the benefits. This scenario adds another profound layer to the mystery of the cosmos. It suggests that every civilization might be a solitary watcher, isolated by the vast gulfs of space and time. The relationship between us and these distant alien civilizations could remain forever one of tantalizing closeness yet insurmountable remoteness, a paradox of being close yet unreachable. In the vast cosmic theater, every civilization may find itself a cautious observer, deliberately concealing its presence to avoid becoming a target for more advanced civilizations. Such a strategy could stem from self-preservation, as the speed of information transmission is limited by the speed of light, while the pace of technological development can vary drastically. A seemingly primitive civilization could undergo rapid technological growth and emerge as a formidable power within a short span of time. Consequently, civilizations capable of interstellar travel might adopt a policy of silent diplomacy, avoiding any actions that would expose their location. This might include deploying sophisticated monitoring systems to detect signs of other civilizations while simultaneously employing measures to obscure their own presence, such as utilizing stealth technologies or minimizing energy emissions during interstellar journeys. Under such circumstances, even if alien civilizations possess the ability to reach Earth, they might choose to remain silent, continuing their covert operations instead of openly revealing themselves. If a civilization at humanity's current Type 1 level could detect their activities, it would be akin to a beacon in a dark forest, attracting the attention of potentially hostile civilizations. Unless they were confident that their technological superiority made them untouchable, they would likely avoid unnecessary risks. As humanity's understanding of the cosmos deepens, it becomes increasingly apparent that Earth's resources are not as abundant as they may seem. Even humanity, still far from achieving a Type 1 civilization status, frequently engages in conflicts over limited resources. On a cosmic scale, Earth's wealth appears even more trivial. A civilization capable of interstellar travel would possess technology far beyond humanity's current capabilities. Such civilizations may have mastered the extraction of energy directly from stars or harnessed advanced resources like neutron stars, black holes, dark matter, or dark energy. By comparison, Earth's resources, minerals, fossil fuels, and other materials humans value, would be laughably insufficient. These resources might not even sustain such a civilization for a fraction of a second. From this perspective, alien civilizations might completely disregard Earth's resources. What humanity treasures, metals, oil, and gas, could be seen as primitive, limited, and inefficient to them. To these advanced beings, Earth might be just another ordinary planet, with neither its natural resources nor its life forms holding any particular appeal. Furthermore, advanced civilizations may abide by some cosmic law or ethical code that respects the existence and development of other life forms, refraining from exploitation or interference. This principle of peaceful coexistence among civilizations could be another reason why they choose not to colonize Earth. Human understanding of dimensions begins with geometry, but in physics, the concept of dimensions holds much deeper significance. Theories such as string theory and quantum gravity suggest that our universe may encompass multiple dimensions, while humanity exists in a three-dimensional space with one dimension of time, a four-dimensional space-time. If alien civilizations have transcended the limitations of lower dimensions and entered higher dimensional realms, interacting with us would become exceedingly complex. Beings or civilizations existing in higher dimensions might have the ability to manipulate lower dimensional spaces effortlessly, much like how humans can manipulate shapes on a two-dimensional plane. However, such capabilities do not necessarily imply a frequent desire to intervene in lower dimensional worlds, as doing so could destabilize those dimensions or produce unpredictable consequences. Thus, even if extraterrestrial civilizations exist in higher dimensions and possess the ability to observe or influence our three-dimensional world, they might choose to remain silent. They may avoid direct contact or colonization of Earth for various reasons, perhaps to prevent interference with our development or because they view our existence as inconsequential in the grander scheme of the cosmos. A particularly philosophical and speculative idea posits that our universe itself may have been created by one or more advanced civilizations. This hypothesis arises from deep questions about the origin of the universe and the search for a first cause. If the universe was indeed crafted by an advanced civilization, these creators would possess unimaginable intelligence and technology, akin to what humans might describe as a godlike civilization. Under this framework, these alien creators may have been quietly observing us all along, much like scientists observing microorganisms in a lab. They might be curious about our development or assessing whether we have the potential to ascend to higher dimensional existence or join the ranks of advanced civilizations. However, for reasons such as protecting us from external threats or adhering to some universal law, they may choose not to interfere directly with our evolution, allowing us to progress naturally. While this theory lacks concrete evidence, it is profoundly thought-provoking. It encourages humanity to reflect on the nature of the universe, life, and civilization, inspiring us to continue exploring the unknown in pursuit of truth. Regardless of whether we ever confirm this idea, the process of contemplating it represents a significant leap in human understanding and imagination.